Alright, hi everyone. So today we have a Div3 contest, and yeah, I will be participating in this. And let me just quickly see if Sublime is working fine. Okay, seems like, and yeah, it is getting recorded, so great. And there are quite a lot of people who've registered for this one, like 26,000 people. That is huge. Okay, here we go. Problem A. Polycarp must pay exactly n pearls at the checkout. He has two nominal values, one pearl and two pearls. Okay, Polycarp likes both kinds of coins equally, so he doesn't want to pay one with more coins of one type than the other. Thus, Polycarp wants to minimize the difference between the count of ones and twos. Help him by determining two non-negative integers c1 and c2, which are the number of coins, so that the value of and the absolute value of the difference between c1 and c2 is as little as possible. Okay. Is as little as possible, and n can be up till 10 to the power 9. So let's say the difference between them is x. So if c1 is greater than c2 by x, then we'll have c1 equals to c2 plus x. Right. So if c1 is greater than c2 by x, then then the whole sum will be 2c2 plus c2 plus x. So that will be 3c2 plus x. Right. Now we need to minimize this x. So this x will be basically n minus, yeah, basically n minus n divided by 3 into 3. So LLX equals to n divided by 3 into 3 n minus. So if we have c1 greater than c2, then this will be the difference. And if c2 is greater than c1 by x, then that means the overall sum will be c1 plus 2c2 plus 2x. Right. So 2x here will be c1 plus x. So here the difference will be again same. So, but we have to, okay. Uh, Here the number must be even, right? Okay. So we can subtract 3 from n as many times as we want, but at the end the number should be even. Right. Okay. So if right, so I just have to find the biggest odd number that I will multiply with 3 in that case. If c2 is greater than c1 by x, then that means the overall sum is 3c1 plus x, 3c1 plus 2x. Right. Okay. So if I'm having a difference of 2, if I'm having a difference of 2, I can reduce it to a difference of 0. Right. Okay, if C1 is greater than C2 by 2, then I can just reduce this. I mean, I can just subtract 2 from C1 and put it into C2. So that will make the overall difference 1. Okay, let's just find out the number of 2's equals to n by 2. LL1s equals to n minus 2 into 2. Right, so these are the 1s and 2's right now. Now, this is insane. Okay, if let's say I decide that both of these numbers are x, but one of them also has an increment. So I can have 3x plus y equals to n, or I can have 3x plus 2y equals to n. Right. And I have to minimize y here. Okay, let's look at problem B till then. And this has like 6,000 submissions, so maybe can I just find out a pattern here? So clearly what they're doing is they're just dividing the number by 3, first of all. This is one number. Val2 equals to 2 into val, right? So if, okay, so now the difference can be only 1 or 2. So if, plus val2 equals to n, then I just simply print this. Else if val1 plus val2 is equal to n minus 1, then I just print plus 1 else I just print val1 and val2 plus 1. Right, this should be fine. Because clearly if I divide the number by 3, then the remainder can be only 2 or 1. Okay, this has to be val2 divided by 2. Similarly, val2 divided by 2. Right, this seems fine. Let's just submit this. 1 0 is fine here, right? Yeah. The idea is basically to divide the number by 3, then the remainder can be 1 or 2. If the remainder is 1, you shift it to the very first number. If the remainder is 2, you shift it to the second number. Okay, so moving to problem B now. B1 and B2, basically there are two versions here. So this is a simplified version of problem B2. Perhaps you should read problem B2 before you start solving B1. Okay. Have a favorite string S which consists of lowercase letters of the Latin alphabet. They want to paint it using pieces of chalk of two colors, red and green. Let's call a coloring of a string wonderful if the following conditions are met. Each letter of the string is either painted in exactly one color or isn't painted. Okay. Right. Each two letters which are painted in the same color are different. Each two letters which are painted in the same color are different. Okay, so you cannot paint, let's say if you have A 5 times, you cannot paint, them as green all fives. The number of letters painted in red is equal to the number of letters painted in green. Okay. The number of painted letters of this coloring is maximum among all colorings of the string which meet the first three conditions. Okay. So there is no adjacent type thing, right? Yeah. So from A, I can only choose one or two. Right. For yeah, right. Right. If we talk about Codeforces here, so this can be painted red, green, uh, red and green again. Yeah. So if we have one letter occurring more than twice, then we can obviously paint it, red and green. Right. So I have 2, 5, 3. Okay, this is fine. Let's submit this. So basically, if there is a character occurring more than 2 times, you pair it with itself, and the others which are left, you can, just pair any one of them, any two of them, like you want. Okay, the problem is an extension of the problem. It has quite many differences, so you should read this statement completely. Okay. Have found a new favorite sequence of integers. They want to paint it using pieces of chalk of k colors. The coloring of a sequence is wonderful if the following conditions are met. Each element of the sequence is either painted in one of k colors or isn't painted. Okay. Each two elements which are painted in the same color are different. Right. Right. Let's okay. So isn't this like exactly same? We just have to, scale it up. Okay, so now they also want the coloring here, right? Second contains, okay. So here, yeah, I can just maintain a frequency array like this. Frequency array of n, basically, because the numbers can be from 1 to n here. Right. So let's just remove this for now. Okay, and let's debug frequency. Okay, so we also need k here, right? One is occurring 4 times. Okay, so we can also maintain, the places where all these numbers are occurring. Okay, there is an announcement. Okay, in case of any technical issues. Okay. Okay, so here again we cannot color them same, right? For the ones that are occurring more than k times, we can be sure that we can color any of them and we will be done. Right. So right, so if the frequency is greater than k, then I can just color k of them. Answer at So here I've already colored those cells which have an occurrence of greater than k, greater than or equal to k. So here 1 has been colored, 10 has been colored. Right. Now how many more colorings can I have? Okay. So here I'll be just, putting them inside a vector where I can just mark them, that I will be coloring them. Right. So I can just, pick up slots of k and I will be done here. Because clearly all these numbers are occurring less than k times. So, I will not be picking up a segment which has same elements occurring, more than k times. Instead, I can just put this. Right, this should be fine. One, two, three, four. This is also fine. One is also fine. Here I'm coloring how many? 1, 2, 3. 1, 2, 3, 4, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So this seems to be fine. Let me just submit this. Okay, great. So moving on to problem C here. Okay, C should be fine. I think we can go for C. Oh, he solved it in 11 minutes. Great. Okay, looking at this problem now. Wants to write a story. He is a very unusual writer. He uses only letters A, B, C, D, E. To compose a story, Stephen wrote out n words consisting of the first five lowercase letters of the Latin alphabet. Okay, he wants to select the maximum number of words to make an interesting story. Let a story be a sequence of words that are not necessarily different. A story is called interesting if there exists a letter which occurs among all words of the story more times than all other letters together. For example, the story consisting of three words B, A, C, A, D, A, E is interesting. The letter A occurs 5 times. Among all, okay, all other letters occur 4 times in total. But the story consisting of words A, B, C, D, E is not okay. No such letter that occurs more than all letters in total. Okay. You're given a sequence of n words consisting of letters. Your task is to choose the maximum number of them to make an interesting story. If there is no way to make a non-empty story, output 0. Okay. So let's say I decide that I want A to be highest. Like I can consider 5 cases here. Let's say I decide A to be highest. Then I would want to pick up strings that have, more number of A's basically. And I think I can do a binary search here as well. Yeah. Picking up strings with more A's should be beneficial here in that case. So I need to choose a subsequence of them, right? Yeah, I need to choose a subsequence. And I want one of them to have an occurrence greater, right? Okay, let me think about this one. Two cells having a common side, it may be horizontal. Okay. The value of n into m is even. Okay, so one of them has to be even, right? A domino is a figure that consists of two cells having a common side. Okay. You need to find out whether it is possible to place n m by 2 dominoes on the table so that exactly k of them are horizontal and all other dominoes are vertical. Okay. Dominoes cannot overlap and must fill the whole table. Right. Exactly, k of them are horizontal. So let's try to draw them here. Right. So for the very first case, we have 4 cross 4. Okay. And we need to place two of them horizontal. Right. Right. Okay. So let's say I decide to place a horizontal domino here. Then what does this mean? Okay, so if I have to place n m by 2 dominoes here, then I have to select n m by 2 cells, and in each of them I have to fill either a 1 or a 0. Right, so if I fill a 1 in one of the cells, the lower cell also gets filled by 1. And if I fill a 0 in one of the cells, then the right cell also gets filled by a 0. So I basically need to cover this whole matrix. So they want me to place exactly k dominoes horizontally. So I think it is better to choose the first row for placing horizontal dominoes because then you have a whole structure below it. if you start placing in the middle, then I don't think it would be possible. Like you are dividing this whole part into two parts. Okay, so here I can place just two dominoes and then like this. They want two dominoes to be horizontal. Okay, so this does not work out here. Okay, so there is one thing here. If I'm given a whole grid and I need to place k of them horizontal, what are the number of test cases here? Test cases are only 10. Okay, so if I just decide that I will be placing a domino, let's say here, of horizontal, I mean a horizontal domino, then I am also fixing this cell, right? And while placing these dominoes, if I'm not placing a domino here, then I have to leave both of these cells, right? Then I can fill here, then here as well. Okay, let's look at it like this, that if we have a single row here, and let's say the length of this row is odd. So what this means is that, I will have to fill, odd places here. I mean, either I can fill one of the one of this whole row. I mean, I'm talking about columns here. If the length of this whole column is, odd, I'll have to fill odd rows with horizontal dominoes. And by doing that, I will be basically selecting another column along with it, right? So if the length of this whole thing is odd, then I need to place odd, dominoes horizontally. If the length is even, then I need to place even dominoes horizontally in every column. Okay. And I also need to leave out some space, so it is better to just start filling on the top. Right. So what I can do is, if let's say I want the first row's length to be odd, I mean I have to fill odd, places in this whole column. Then I can just select the first one, the second one, the third one, or let's say 5 I select. Okay, so I'm done with 5 dominoes now. Then this whole row is, it is just discarded now. Now in the next one, okay, so what this is telling me is that if there are uh, odd rows, there have to be even columns. So that I already have my condition, right? Right. So I just need to decide if there are odd rows. Yeah, if there are odd rows, then there are even columns for sure. So I just have to see if k is divisible by 2 or not. In that case, k is divisible by 2, and It has to be, K has to be a sum of m by 2 odd numbers, right? So K has to be even first of all, or does it have to be even? Because I'm covering K of them. So if there are odd rows, yeah, if there are odd number of rows, then for every column I will have to pick some odd number of horizontal dominoes here. Right. So for every column I have to pick at least one, right? Yeah. So for m by 2, I can just subtract m by 2 from k minus m by 2. So k has to be greater than m by 2 first of all. And subtracting m by 2 from k should give me an even number. So this is for the case where when there are odd rows. We'll have to think about a case when there are even rows. Right. So if n modulo 2 is not equal to 0, then m has to be even first of all. So if k is greater than m by 2 and k minus m by 2 modulo 2 equals to 0. Right. So if this is the case, then I'm done. Else I just print no. Right, now I have to consider the other case. So if k okay, so if the number of rows are even, now this is an issue if the number of rows are even. Right, so the first thing is that you can you can only place even number of dominoes in every column. So if you pick up the first two columns and you place, let's say, even number of dominoes there, so you're placing even number of dominoes in every row. Let's look at some cases here when the number of rows are odd, 3, 2 and 3. So I need to place 3 of them, right? So this can be possible. 5, 2, and 2. Okay, let's look at the other cases. Are they working fine now? Okay, yes, no is fine, then no is fine. Okay, so I am talking about the case where there are even number of rows. So basically I can consider 4 cross 4. So I can place it like this, right? So if you have k as even here, will it work? If let's say I had 3 here, would it have worked? So for 3, what I could have done would be something like this. But this doesn't work out. I think for this case k has to be even. Yeah, this seems to be fine. Let me just submit this. Okay, wrong answer on test 3. So I don't get to see the test cases here. Maybe there is some issue with this part where I'm saying k has to be even. Okay, so if the number of if the rows are basically even, then the columns can be odd or can be even. So in every row, I can just place 2k type of dominoes, and then these 2k will be shared by one of the rows, adjacent to this row, the left one or the right one. Yeah, I think K has to be even in this case. But I think there is some issue with the upper case here. If there are odd rows, what do I do? If there are odd rows, then there have to be even columns. And for every one of them, I have to place at least one in them, like one domino. Okay, this is not totally necessary that that I put it like that only. This is not necessary here. So in the very first one, I can put one domino. So if K is greater than m by 2, is it always possible? The number of dominoes that are left should be even, I think. Okay, what if he wants to place all of them, So what about this? So we have, okay, I missed something here. If we had one here, what about this? So it changed to no. And why no? Because okay, why is this had to be greater than equal to 0 first of all? Okay, still getting wrong answer. Fine. So if I want to place 2 here, 2 should not work, right? And let's say this was 4. Now if I have 4 here, this should also not work ideally, but it is giving me a yes, right? No, no, this can work. This can work. I think if both n and m are, if they both are even, then anything works. Right, if n modulo 2 equals 2. Right. So here k equals to n into m divided by 2 minus k. So I am doing the exact same thing here. Let's test it here. Obviously, right now I'm not testing it, properly. I'm just making a guess here. Something that seems intuitively correct to me. Yeah, this seems to be fine. Let's submit it. Wrong answer on test 2. So if both of them are even, then is it necessary that, okay, it is actually necessary that k also has to be even in this case. I don't know, maybe maybe they should have provided a sample test case where it was failing. Okay, so that was basically a guess that I don't know how it is working. I cannot code D2 because yeah, I don't know how it is actually working. So let's look at E till then. And C has like a lot of submissions. Okay, consider a sequence of integers a1, a2, so on up till an. In one move, you can select any element of the sequence and delete it. After an element is deleted, all elements to the right are shifted to the left by 1, so there are no empty spaces. Okay. Uh, okay. A3 equals to 2 in a move. Then after the move, the sequence will become this. So the third element is removed. Right. You're given a sequence A and a number k. You need to find the minimum number of moves you have to make so that the resulting sequence in the resulting sequence there will be at least k elements that are equal to their indices. Oh, okay. There are at least k elements that are equal to, okay. If there is no desired sequence, you need to place at least k of them on the right positions. At least k of them should be on the right positions. Okay, so for each number you can decide what is the number that needs, I mean how much it has to be shifted to be brought to its right place. Okay. Can I do a DP here that if I'm standing on the ith index and I have removed j characters, I mean j elements? Okay. I think I can do a DP here. If I'm standing on index I and I have removed j characters, then for the next one I have two possibilities, right? So int n comma k, right? So what I can do is, so I'm going to do a recursive DP here. I'm not sure how the states would look like if I do it iteratively. So it's better to do it recursively here. So I'm on the 0th index, I have removed 0 characters, ARR is greater than equal to k. Okay, minimum number of moves. So that would become like an order of n cube dp then. I also need to find out the minimum number of moves. Okay. Okay, if I can define my DP in a different way, if I'm on index I and I have removed j characters, then how many elements are on the right positions now? If that can be my DP. Yeah. So how do I transition in that DP? Like I am standing on index I and I have removed j characters, then how many of them are on the right positions? Okay, let's look at C till then. Maybe we can find out a solution to C. So we're getting 0 for which case? For the third one. This is the third one. Okay, so this will be 0 because you cannot pick one of them. Neither can you pick both of these. Okay. In the fourth test case, okay, if we talk about this test case, why can't we pick C, CA and B as well? He wants to select the maximum number of words to make it an interesting, okay. Oh, okay. Okay, so we have to find a letter, which occurs. Okay, I had completely understood the problem in a wrong way. I was thinking that whatever character that we choose, it has to occur maximum number of times compared to the other characters. But here we are talking about the total sum. So yeah, I think this can be done. Okay, so cat s at j minus I. Okay, cool. So I basically have to consider 5 possibilities here. अरे यार plus equals to okay k comma j. Now we just have to, basically I can just consider it like one variable, sum2 sum1 okay k comma j. And I can just sort it now. Right. Sum plus equals to violet, let's do it k. Sum1. Now what is the issue? Okay, this has to be int. So I'm getting 320232. Okay, this is fine. Now I had understood the problem in a completely different way. This is what was not actually required. Okay. Okay, I don't think I can do D2 now, considering a very small time. I mean, very less time is remaining. So I would be ending the recording here. Like, if there is anybody who would like to join, a post contest discussion live with me, then you can obviously join my Discord server. And apart from that, I don't usually have these, contest discussions publicly. I usually have them in my TLE Eliminators membership. So yeah, if you want to attend them live, you can obviously buy that membership. So yeah, I will be having that discussion today as well. So in case you're interested, you can buy the membership.